Alright, what is going on, my physics Padawans? And today we're going to be going over the fifth example from the energy unit. And we're dealing with force versus distance graphs, or force versus displacement graphs. And we're going to be trying to find work that is done from it. So in this problem, we have a crane. And as you can tell from this graph, this crane right here is exerting different forces at different distances on our object. So, usually when a problem asks us to determine the work being done, your first type of step might be, okay, I know the equation for work. That's going to be the force times the distance times the angle between those two things, the cosine of the angle between those two things. But the problem arises when we have a problem like this. If we want to use this equation, we can only plug in one number for force right there. And the problem is all of these parts, the force is changing. There's not just like one single number we could plug in. So when you have a graph, generally for us to actually find the work being done, well, in this equation, it's force times displacement right there, which means that, two things being multiplied together. If we have a graph of these two quantities right there, force and distance, then if we multiply those together, we'll be able to find what that equation is. So because they're being multiplied together, we're going to find the area of our graph. All right, so the area of this shape right here, this is a trapezoid. So we're going to go area of a trapezoid, 1/2 the sum of the two different bases times the height. So when we look at this, we have the top base goes from 10 to 50 meters. So this top base right here, that whole part is 40 meters long. Okay, and the bottom is this entire piece. The bottom is 60 meters long. So when we plug in what we know, that's 1/2. 40 meters plus 60 meters. And then the height of this thing, over here on the side, you just need to look at how tall the object is. It goes from 0 to 10 newtons. So the height of this is 10 newtons. So once we multiply all that stuff out, right, 40 plus 60 meters becomes 100 meters. That's still 10 newtons and 1/2. So when we multiply all that stuff together, we end up with the area being the work. So we have the work of 500 Newton meters. Well, remember, 1 Newton meter is equal to a joule, so we have a work done of 500 joules right there. Okay, so just remember, a force versus distance graph, we can use the area to get the work being done. All right. I will see you guys later. If you have any other questions or anything, bring them up in class, and adios.